In today's class, we'll see Gomory's cutting plane algorithm. We'll be solving this one problem by using this Gomory's cutting plane algorithm. So in this Gomory's cutting plane algorithm, before we apply this, we will be using the simplex method. So I hope you all know now the simplex method, how to solve a problem using the simplex method. So let us consider one example. So I will solve using the simplex method. Then we will be applying actually this Gomory's cutting plane algorithm. So let us consider the example. Max z is equal to 2x plus 3y subjected to the constraints 2x plus 2y is less than or equal to 7, x is greater than or equal to 2, y is greater than or equal to 2, x and y is greater than or equal to 0 and are integers. So this is my problem. So to solve this problem, I have to apply the normal simplex method solutions. So how will you solve the simplex method solution? First you have to convert this into the standard form. So how will you convert? If the constraint is less than or equal, you have to add the slack variable. Less than or equal, so you have to add the slack variables. So I'll add the slack variable here. So 2x plus 2y plus slack variable equal to 7. X is less than or equal to 2. So x plus slack variable 2 is equal to 2. And we have one more constraint, y is less than or equal to 2. So y is plus slack variable 3 equal to 2. Now you have to write the maximization of your objective function. Max z is equal to 2x plus 3y, and you have to include now here the slack variable, but the coefficients will be 0 for that. So 0 into s1 plus 0 into s2 plus 0 into s3. Now as we used to do, you write a simplex method table. So here the simplex method table, it begins with BV, CB, XB and your variables X, Y and then your slack variables S1, S2, S3 and the last the column will be the minimum ratio. So here you have to write Cj, which indicates the coefficients. Now BV indicates the basic variable, CB indicates the corresponding coefficients, XB indicates its RHS, X and Y and S1, S2, S3 are the variables. Now Cj, you have to write the coefficient from your objective functions. So X coefficient from your objective function is 2, Y coefficient from your objective function is 3 and S1 coefficient is 0, S2 coefficient is 0 and S3 coefficient is 0. Fill the table here. This indicates BV. BV indicates the basic variable. Here the basic variables we are considering 3 variables S1, S2, S3. These are our basic variables. Now CB indicates indicates the coefficient, corresponding coefficient of this basic variables. S1 coefficient you can see here 0, S2 coefficient you can say 0, S3 coefficient is 0. S1, what is XB indicates the RHS. So S1, what is the RHS of this equation? 7. The RHS of the second equation is 2 and RHS of third equation is 2. Now we will start filling this table. From the first equation where you have added your slack variable S1, what is the coefficient of X? 2. What is the coefficient of Y? 2. And what is its coefficient of S1? 0. S2 is not there, so 0. S3 is not there, so 0. From the second equation, X is 1, Y is 0, S1 is 0, S2 is 1, S3 is 0. From the third equation, X is 0, Y is 1, S1 is 0, S2 is 0, S3 is 1. Now, after filling this table, you have to find out Zj. What is Zj? Zj, summation of Cb into Xj, or we can write in generally Aij. So here to write Zj of this value, you have to multiply this 0 into 2, 0 into 1 plus 0 into 0. This gives you 0. 0 into 2 plus 0 into 0 plus 0 into 1, which gives you 0. So here also 0, here also 0, here also 0, 0. Now, the next one will be Zj minus Cj. This value minus this value. So 0 minus 0 minus 2 is minus 2, 0 minus 3 is minus 3, and 0 minus 0 is 0, 0 minus 0 is 0, 0 minus 0 is 0. Now, here our objective function is maximization. For maximization, the optimality condition is Zj minus Cj should be greater than or equal to 0. This is the optimality condition. Is our Zj minus Cj is greater than or equal to 0? No. This indicates we have to find out the optimal solution by continuing to the next iterations. Now, to continue to the next iterations, we have to see here the most negative number. So we can see here the most negative number is minus 3. The column correspond to this will be the entering variable. Now, to find out the leaving variable, so now you have to consider this column. Now, here to find out the minimum ratio, your xb divided by value in the entering column. So, xb divided by value in the entering column. What is xb? X7 divided by 2. 7 divided by 2 gives you 3.5. 2 divided by 0. Whenever something divided by 0 or whenever you have something negative number, you can leave this blank. 2 divided by 1. 2 divided by 1 will be equal to 2. As the name itself indicates, it's a minimum ratio, which is minimum among 3.5 and 2. So, 2. This is considered as your leaving variable. So, this is your leaving variable. So, I will mark this one as a leaving variable. This is entering variable, and wherever this leaving variable column and the entering variable column coincides, this is called as pivot value. This is called as pivot 1. Now we'll move to the second iterations. So this is iteration 2. What we have to do, this is our new row now. We have to fill the table again. So I'll write here this BB, CB, XB, X, Y, S1, S2, S3. This is the minimum ratio. And here we have our CJ values. BB, CB, XB, XY, and these are our minimum ratio. And now S1 row I have to write, S2 also variable I have to write. Now S3 is a leaving, Y is entering. So instead of S3 I have to now this write here Y. So Y will be the entering variable. Now S1, again you have to write the coefficients here, 2, 3, 0, 0, 0. The CB indicates the corresponding coefficients of this. S1 coefficient is 0, S2 coefficient is 0, Y represents 3. Now this is our new row. So to find out the new row, the formula is the old value divided by your pivot value. So what is the old value here? 2 divided by pivot is 1. So 2 divided by 1 is 2. 0 divided by pivot is 0. 1 divided by 1 is 0. 0 divided by 1 is 0. 0 divided by 1 is 0. 1 divided by 1 is 1 itself. Now, to fill this table, the formula is old value minus new value into value in the entering column. So, for this row 1, I'll just represent this as a row 1, this as a row 2. Old value. What is old value? Old values are 7, 2, 2, 1, 0, 0. Minus. What is the new value? New value represents this. So, 2, 2, minus, minus, minus. So, new value represents this. 2, then 0, then 0, then 0, then one more 0, then 1. Into, for the first row, what is the value in the entering column? The value in the entering column will be 2. So, this you have to multiply. Into 2, into 2, into 2, into 2, into 2. So, write this value. 7 minus 4 gives you 3. 2 minus 0. So, 2 minus 0, 1, 0, 0 minus of 2. So, minus 2. This you have to write here now. So, 3, 2, 2, 1, 0, 2. Minus 2. Similarly, now you have to find out the value for row 2. So, apply the same formula. Old values, these are the old values, minus new value into value in the entering column will be now 0 here. So, I will directly, instead of this calculation, since it is a very big problem, I will directly write the answer and later I will upload this, completely I have solved this one. So you can go through this, and if any mistakes or if any changes, you can change according to that. So, and as of now, I will directly write this values. So here it will be 2, 1, 0, 0, 1, 0. Now since this table is filled, I will erase this. So as we used to do, we have to find out now Zj, then Zj minus Cj. These values I have to fill. Now, what is Zj? This into this plus this into this plus this into this. 0 into 2, 0 into 1, 3 into 0. So you will get here 0. 0 into 2, 0 into 0, 3 into 0, you will get, here we are supposed to get 1. Yeah, 1 minus 2, 0. Here this is our pivot 1 by 1. We will get 1 itself. So 0, 0, 1. So we will get here 3, and 0 into 1, 0 into 0, 3 into 0, we will get 0, and 0 into 0, 0 into 1, 3 into 0, we will get 0 here. 0 into minus 2, 0 into 0, 3 into 1, we will get 3. Now Zj minus Cj. 0 minus 2. So I will get minus 2. 3 minus 3 will be 0. 0 minus 0 will be 0. 0 minus 0 will be 0. 3 minus 0 will be 3. So for the maximization function, what is the optimality condition? Zj minus Cj should be greater than or equal to 0. So since we got here negative number, this is not the optimal solution. Still we have to continue for the second iterations. So to find out the second iteration, we have to find out the entering row as well as the entering the column. Now the most negative number, since we have only one here, this represents the negative number. So this will be our entering variable. Now to find out the leaving variable, what we have to do? The xb divided by value in the entering column. 3 divided by 2. 2 divided by 1. 2 divided by 0. 3 divided by 1 will be 1.5. So here we need actually minimum ratio. 1.5 and 2, the minimum will be this. So this will act as our leaving variable, and this represents the pivot. Okay, so this is x is entering variable, s1 is a leaving variable, and this represents the pivot. Now we have to continue for the third iterations. Next we'll continue to the third iterations. So the iteration 3 will be now s1 is a leaving variable, x is the entering variable. So x will enter here and s1 will be leaving. So instead of s1 you have to write now x itself. So again you write bv, cb, xb, x, y, s1, s2, s3, minimum ratio. This is your Cj. Now, coefficients you have to write again. This is 2, 3, 0, 0, 0. And the basic variables you have to write now. Instead of S1, X is entering. So you have to write X, S2 and Y. X, this is our now new row. So how will you find out the values for this? I'll first write the coefficients. X coefficient is 2, S2 is 0, Y coefficient is 3. Now, you have to find out fill this first row now. So whatever the old value divided by the pivot. Old value is 3, pivot value is 2. So 3 divided by 2. 2 divided by 2 is 1. Then 2 divided by 2 is 1. 1 divided by 2 is 1 by 2. 0 divided by 2 is 0. Minus 2 divided by 2 is minus 1. How will you fill these two rows? So, same again apply the same formula. Old value minus new value into value in the entering column. Again similarly you apply the formula to the second one also. Old value minus new value into value in the entering column will be 0 here. So I will not do that calculations. So since we already finished and you are very familiarized with this, how to find out the values, I will just directly write the values. So here it will be 1 by 2, 0, 0, find out the, might be I have done some mistake here. Everyone check here in this place, might be you will get 0, not sure with this one, you check once again. So now Zj value here is, so now 2 into 1 plus 0 into 0 plus 3 into 0, so you will get here 2. Now 2 into 1 plus 0 into 0 plus 3 into 1, you will get, yeah, as I said, here you will get 0. So you will get here 3. Here you will get 1, here you will get 0, here you will get 1. Now, Zj minus Cj. Zj minus Cj. 2 minus 2 is 0. 3 minus 3 is 0, 1 minus 0 is 1, 0 minus 0 is 1, 1 minus 0 is 1. Now, for the maximization problem, what is the optimality condition? Zj minus Cj, optimality condition is Zj minus Cj should be greater than or equal to 0. So, if you observe here, it is greater than or equal to 0. So, we have to stop the iteration here and we have to write the values of x, y and our z values. In this iteration we can see now Zj minus Cj, all the values are positive and the optimality condition for maximization is Zj minus Cj should be greater than or equal to 0. So all the Zj minus Cj values are greater than or equal to 0 here. So we have to stop the iterations here. Write the values of x and y. So the value of x is equal to 3 by 2. The value of y equal to 2 and value of z is equal to 2 into 3 by 2 plus 0 into 1 by 2 plus 3 into 2. 2 into 3 by 2 plus 0 into 1 by 2 plus 3 into 2. we will get 3 plus 6 equal to 9. So we got the value of x is equal to 3 by 2, y is equal to 2, z is equal to 9. But in our problem, if you observe, these values should be integers greater than or equal to 0 and should be integers. So since it is not integer here, we have to solve this using the Gomory's cutting plane algorithm. So the second phase, step 2, will be generating the Gomory's constraint to convert this fraction into integer. So step 2 is generating the Gomory's constraint. So consider these values again here. X is equal to 3 by 2, y is equal to 2. Now represent this as a part of integer and fractions. Here also integer and fraction. So I'll just for the representation I'll write this as integer plus fraction for x, integer plus fraction for y. I will represent this x is equal to integer. How I can write this as integer? 2 plus 1 by 1 plus 1 by 2. So 2 plus 2 into 1, 2 plus 1 we will get actually 3 by 2. So integer part, fraction part. So how will I represent this y here? Integer is 2. Since there is no fraction, we will be representing this as 1 plus 1 by 2. This as 2 plus 0. Now we have to find out the maximum of fraction of fx plus fy. What is fx here? The maximum of the fractional part of x is 1 by 2, comma, the fractional part of y is 0. So we will get the maximum here is half, that is from the variable x. Now what we have to do? We have to add or generate the constraints. This indicates we have to generate the constraint for this row x. Okay, for this row x. So maximum here is half. We got this half from x. So x we have to consider from the last table. I'll just erase this one because I need this last table. Now, I have to consider this. So here you have to write, see, 1 into x, 1 into x plus 0 into y plus 1 by 2 into s1 plus 0 into s2 plus becomes here minus 1 into s3 equal to, what is its solutions? 3 by 2. That is solution indicates here xb. This is equal to 3 by 2. So again this values I have to represent in integer fraction. This as integer fraction, integer fractions, integer fractions. So first I will simplify this. 1 into x, since it is 0 into y, I will not consider this. Half into s1 minus 1 into s3 equal to 3 by 2. Now I have to represent this as integers and fractions. So I will write 1 as integer is 1, fraction is 0 into x plus. Here, what is the integer part here? 0 plus fraction part I will write as half into s1 plus here it will be minus 1 I have. So I have to write this as integer 1 since there is no fraction. 0 into s3 equal to this 3 by 2. How can I represent this in terms of integers and fractions? This will be 1 plus 1 by 2. I hope it is clear to you. See these values, again I have to write integer fraction, integer fraction, integer fraction, integer fractions. Now, here you have to consider only the fractional part now. So here if I consider the fractional part, this is 0 into x plus half into s1 minus 0 into s3 equal to, here the fractional part is half. So this becomes 0 into x becomes 0, 0 into s3 becomes 0, the remaining will be half s1 equal to half. And we can observe here for any value, s1 is an integer and it should be usually greater than or equal to 0. So since it is this part has greater value, so we'll be converting this into greater than or equal. Now we have to always, for the maximization, the symbol should be less than or equal. So to convert from greater than or equal to less than or equal, what you have to do? You have to multiply -1 to both RHS and the LHS. So this becomes here minus half into s1 less than or equal to minus half. Now to convert this into or to equate this, usually what we used to do, we used to add the slack variable. Now instead of slack variable, we have to add the Gomory's constraint. So this becomes minus 1 by 2 s1 plus add here Gomory's constraint, let's call this as g1 equal to minus half. This is the equation which represents the Gomory's constraints. Next we have to consider this equation to our last table. Now this is the Gomory's constraints is expressed. Now what you have to do, these values, this equation you have to consider in the last table. So here the last table, you can rewrite the same table again. So I will use the same table. I'll just erase this zj minus ej, and the last column will be our now the Gomory's constraints or the expressions. And instead of minimum ratio here, now I have to consider this G1 also, Gomory constraint G1. And here also I have to consider the Gomory constraint G1. Yeah. How will you fill the table? G1. So for this, what is the solution or the answer? Minus 1 by 2. So that I have to write, this represents the coefficient. So in the objective function, the coefficient of G1 will be 0. So I have to write here 0. Now for xb, the RHS. So here it will be minus 1 by 2. And how will you fill the table? X. Do you have x in this equation? No. So you have to write here 0. Now x is not there in this equation, so this becomes 0. Y is not there in this equation, this becomes 0. S1 is there and its coefficient is 1 minus 1 by 2. So that you have to write here minus 1 by 2. S2 is not there, so this becomes 0. And S3 is not there, this becomes 0. And Gomory's constraint you have, so this becomes 1. Rest all for the other equation, since we doesn't have Gomory's constraint, this becomes 0. Now you have to find out the Zj. So Zj will be equal to, you know, Cb into x, so plus 0 into 0 plus 3 into 0 plus 0 into 0. So in this equation we will get 2. So you have to find out, and all the calculations are done here. You can refer this. I will write the direct answer. 2, 3, 1, 0, 1, 0. Now the next step is you have to find out Zj minus Cj. Zj minus Cj. So Zj minus Cj. So 2 minus 2 becomes 0. 3 minus 3 becomes 0. 1 minus 0 becomes 1. 1. And 0 minus 0 becomes 0. 1 minus 1. 1 minus 0 becomes 1. 0 minus 0 becomes 0. So if you observe here, Zj minus Cj, all the values are positive. Does it mean that we have to stop here? But if you see here, your solution or the xb values, you have negative values. So if Zj minus Cj is greater than or equal to 0, and this says yes, the optimality condition is satisfied, but since here solution you have a negative value, it indicates it may not be the feasible solutions. So we have to go for the dual simplex method. So how will you find out the dual simplex method? Again, so since here in the xb the negative value is g1, so you have to consider this itself as a leaving variable. Okay, this will be the leaving variable. To find out the entering variable, you can observe here you have here positive value, and here also you have positive value, and we can consider this as a entering variable, and this minus 2 becomes the pivot. Now the steps continues how we used to do. So one more iterations, and you have to find out all the values. In the previous table we found S1 is entering variable and the G1 is a leaving variable. So you find out the values of that G1 row just by finding the old value divided by the pivot value, and all the remaining values you have to find out by using old value minus new value into value in the entering column. So I have calculated all the values here. So all these calculations as of now I will not do here. If you want to refer, you can refer this. I will provide these sheets to you, or you have to do it individually. So there might be some minute mistakes will be there. So don't copy from the board. It's always better you have to do by yourself. So I'll directly write the values x, s2, y, and we need here one more column, s1, and this is for zj, and one more column will be zj minus cj. Write all the coefficients of the coefficients from the objective functions 2, 3, 0, 0, 0. Now fill this table. The coefficient of x is 2, s2 is 0, y is 3, s1 is 0. Now find out the values here. 1, 1, 0, 0, 0, minus 1, 1. 1, 0, 0, 0, 1, 1, minus 1. 3, 2, 0, 1, 0, 0, 1, 0. 0, 1, 0, 0, 1, 0, 0, minus 2. Zj will be 2, 3, 0, 0, 1, 2, and Zj minus Cj will be 0, 0, 0, 0, 1, 2. Now if you observe in this table, Zj minus Cj, what is our optimality conditions for maximization? Zj minus Cj should be greater than or equal to 0. Yes, it is satisfying our constraints, and you have to see all your xb values. All the xb values are positive here. So you have to stop the iterations and you have to just write down the values of x, y and find out the value of the objective function. X value here, x is equal to 1 and y value equal to 2 and z value equal to, you have to multiply cb into xb in the last table. So 2 into 1 plus 0 into 1 is 0 plus 3 into 2 plus 0 into 1 is 0. Here you will get 2 plus this is 6 equal to 8. So your z value will be equal to 8. And all these x value and x and y values are integers and greater than or equal to 0. So this is how you have to stop the iterations. Thank you.